In this video, we go over what you need to know about Azure Network Security Groups and Application Security Groups. Hello everyone, I'm Travis and welcome to my channel. I started out with the idea of a quick video on network security groups. Things snowballed from there and I ended up with a fairly comprehensive review of network security groups, or NSGs, and application security groups, or ASGs. I also added some bonus content on verifying IP flow. This is intended as an introduction, but even if you've been using NSGs for a while, stick around because there may be some new information in here for you. Before we get started, please like and subscribe. Subscribing lets me know you appreciate these videos. And click the bell icon for notifications of new content. For some reason, YouTube won't alert you when new content is posted unless you click the bell, and you don't want to miss out. I have courses available at udemy.com on Azure Virtual Desktop and Azure AD with Windows AD, and a new course on Windows 365 Enterprise Cloud PCs. Take a look at the links below. And I also want to thank my channel members. Your support is appreciated. Back to it. Let's start with network security groups. You can think of these as a type of firewall. More accurately, it's like an access control list that can be placed on a network interface or subnet in Azure. An NSG is a group of rules that restrict or permit access to Azure network resources. It uses 5-tuple information to evaluate a rule, including the source, source port, destination, destination port, and protocol. The rules are directional. They can be applied to inbound or outbound traffic. They have an action to deny or allow, and a priority from 100 to 4096. We have a few options for the source and destination on an NSG. Any means just that, any traffic. We can specify an individual IP address or a block of IP addresses. We can target service tags, a group of resources managed by Azure, or an application security group. Be sure to stick around to the end of this video where we review application security groups. We can specify a port or a range of ports or both. We can select a protocol including TCP, UDP, or ICMP. ESP and AH are also available if we deploy the network security group with an ARM template. Any specifies any protocol. There are predefined services that set the port and protocol for you. For example, HTTP will set TCP port 80 and MS SQL will set TCP port 1433. Let's put this together with an example. In this example, we have a client on the 10.100.1 network accessing a web server on the 10.101.1 network. The rule specifies any traffic from the service tag virtual network coming from any source port going to the 10.101.1 network, port 80, with the TCP protocol is allowed. Let's add another rule after that. This one has the priority of 600 and specifies any traffic from one virtual network to another is blocked. The client still has access to the web server because rule 500 matches first and all processing stops after the rule is matched. If we switch priority, giving the block rule the priority of 400, the client would not have access to the web server. The highest priority rule blocks the connection. Each NSG comes with a set of predefined rules. There are inbound rules that allow traffic from other virtual networks. This way Azure resources can communicate with each other. There's a rule that allows traffic from Azure load balancers, and the last inbound rule blocks all other traffic. The default outbound rules allow traffic to other virtual networks, allows traffic to the internet, and then denies any other outbound traffic. Default rules can't be changed, but they can be overridden with higher priority rules. For example, if the goal is to block internet access, create an outbound rule with a priority of 4000 to block internet access. Here's an overview of how we associate an NSG to control traffic. We can apply the NSG to a virtual NIC in Azure. The NSG rule controls inbound and outbound traffic. In this case, the traffic flow to the resource is controlled by the NSG. We can also apply the NSG to the subnet. We could control traffic to and from the internet at the network interface or the entire subnet in this example. If we're accessing resources on another Azure subnet, we have additional locations to control traffic flow. That gives us 4 locations to control traffic between resources. This could make troubleshooting connectivity issues difficult. Microsoft recommends using NSGs at the NIC or the subnet, not both. This will avoid conflicting rules. There is a tool available to troubleshoot connectivity issues. We can use the Network Watcher IP Flow Verifier to identify if packets are allowed or denied between Azure resources. It also lets us know what NSG and Rule blocks traffic. We'll see this in the upcoming demo. This is the environment we'll use for the upcoming demo. We have two clients. Client 1 is on the client subnet and client 2 on a subnet called default. There are two web servers on a web subnet. The goal is to use NSGs to control access to the web servers. The clients have NSGs attached to their NICs with the default rules. We'll start by creating a new NSG and apply it to the web subnet. Let's move to the portal to get started. Here we are in the Azure portal. Let's search for NSG for Network Security Group. We'll create a new one. Provide a resource group. I have one already called NSG Test RG. There it is. We'll give it a name. Let's call it webin-nsg. Set the region. For this example, I'll use East US 2. Go to Review and Create. And Create. We'll give that a minute to finish. That's done. Next, we're going to configure rules to allow web traffic in. Let's go to the resource. The default rules allow inbound traffic from virtual networks and Azure load balancers, and blocks all other incoming traffic. There are default outbound rules as well. They allow access to other virtual networks and the internet, but deny everything else. We're going to modify the inbound rules for this example. We want more control over who can access the web VMs. We'll allow web traffic from the client VNet, but block all other incoming web traffic. Let's create new rules that allow inbound web port 80 and 443. Go to Inbound Security Rules. Add a rule. Select a source IP address. And this can be a single IP address or a block of IP addresses. We'll add the block of IP addresses assigned to our client subnet. Leave source port range as any or wildcard. And we'll leave destination to any as well. We could set the service to custom and define our own port ranges, but let's change the service to HTTP. And that automatically selects destination port ranges 80. We'll leave the action as allow and scroll down. Change the priority to 1000. We can set the priority anywhere between 100 and 4096. It's a good idea to leave a little space in between your rules in case you need to insert a new rule between existing ones. We'll just modify the name. We'll call it Allow Client HTTP Inbound. Add a description if you'd like, and click Add. We'll step through the process again, this time adding a rule for HTTPS. We'll select an IP address. Add our IP address range for the client subnet. Service this time is HTTPS. That's port 443. We'll allow, and we can leave it at 1010. And here we'll change the name again. You don't really need to change the name, but I just kind of like it for this example. And add. So really, we've accomplished nothing technically with these rules. What we've done is said any traffic going to port 80 or 443 from our subnet, which happens to be on a virtual network, is allowed. But those rules are included in Rule 65,000. That allows any port, any protocol between VNets. So what we're going to do next is we're going to create blocking rules. Let's add a rule. This rule will specifically block web traffic. So the source is any, the destination is any as well. Set the service as HTTP, and we'll deny. And we can leave the same priority. And you see we have a warning there because we are doing a deny on web traffic. That's okay for this example. Click Add. We'll add another rule. Any source, any destination with the service HTTPS. We'll deny and leave the priority. The rules are processed from top to the bottom and stop when one is matched. We allowed web traffic from our client subnet and then block all other traffic. If we didn't have these two blocking rules, the rule 65,000 would apply, allowing any virtual network traffic. So with this order and these rules, Any web traffic coming from the client subnet is allowed. If the web traffic is not coming from the client subnet, it's blocked. This example shows how to prioritize rules to allow and deny traffic. Network security groups can be associated at the network interface or subnet. For example, we can go to network interfaces, then associate. Notice we have 2 available and 1 is not available. That virtual network interface already has a network security group associated. We can't associate more than 1 network security group to a networking interface. By the way, if you don't see a networking interface, it may be there are none in the same region as the network security group. NSGs are region specific. But we don't need to associate an NSG to a specific NIC. We can also associate a network security group to a subnet. Let's go to subnets. We'll associate. We'll select our web server virtual network and subnet. So this is the web server subnet. Click OK. Now the network security group is associated to the web server subnet. Let's go to one of our web servers next. We'll go to networking. This shows the effective rules on the server. We have our 4 custom rules, 2 that allow and 2 that deny. Now that we have our network security groups in place, let's test and verify. As a reference, we have 4 computers in this lab, 2 web servers on the web subnet, client 1 on the client subnet, and client 2 on the default subnet. We configured the network security group to only allow web traffic from the client subnet. Let's verify. Here we are on client 1. From here, we can access the web page on web 1, which is 10.100.2.4. We can also go to 10.100.2.5, which is web 2. Let's move to client 2 on the default subnet. Here we are on client 2. I know it looks the same, but it is a different computer, trust me. If we try to open the web page on web 1 at 10.100.2.4, after several seconds, it'll time out. The same happens with web 2 at 10.100.2.5. That times out as well. That demonstrates that we can access the web servers from our client subnet, but not from the default subnet, just like we specified in the network security group. To demonstrate the network security group rules more, let's go into the Azure portal and update the outbound rule for client 1. From client 1, go to networking. We can see the client 1 NSG networking security group is attached to the networking interface. And if we go to outbound rules, we have the default set of outbound rules. Let's create an outbound security rule. We can do that right from here. Go to add outbound port rules. Leave the source and set the destination to IP address. Add the IP address of the second web server. So for this example, it's 10.100.2.5. We have to use the CIDR notation for this, so a /32 at the end indicates a single IP address. Set the service to HTTP and the action to deny. We can leave the priority in the name and click Add. We'll wait for that to finish. And once it's created, we'll go back to client 1. Here we are on client 1. Let's go to web 1 first. That's 10.100.2.4. That works. And now let's go to web 2. 10.100.2.5. That fails because we blocked access to the web page from this server on the NSG attached to the virtual network card. By the way, if you were able to access the website, you may have to close and reopen the web session. Sometimes the sessions will stick until the web browser is restarted. We have 4 places where we could apply network security groups that could potentially block traffic. The NSG on the network cards at the source and destination, and the subnet at the traffic source and destination. It could be problematic to track down network issues if we have a lot of rules in place. Let's take a look at how to verify IP flow and make troubleshooting easier. In the Azure portal, search for and go to Network Watcher. From here, go to IP flow verify. This gives us a place to verify IP traffic and identify where traffic may be blocked. We need to pay attention to the settings we use to keep traffic flow in mind. For example, let's say we're trying to figure out why client 1 couldn't access Web 2 from the previous example. Let's start with an inbound test on Web 2. Select the web server resource group and then the computer. Web 2 for this example. If there were multiple network interface cards, we could select the specific one from here. HTTP is a TCP protocol, and we're testing inbound connectivity. We'll scroll down. The local IP address is 10.100.2.5, and we're testing for port 80. The remote computer, client 1, is at 10.100.1.4. Source traffic uses random ports. We can enter 65,000 for this example. And check. We'll give it some time to finish. It finished. We'll scroll down, and it says access is allowed. And that is correct. We allowed traffic from the client 1 subnet to the web VNet. It's only checking the inbound flow to the web server. Next, let's check outbound traffic from client 1. We'll scroll up, select the client resource group and VM. Client 1 for this example. Leave the network interface and protocol, but change the direction to outbound. The local IP address is 10.100.1.4. The source port for outbound web traffic is random, set it to 65,000. For the remote IP, set it to the IP of Web 2, 10.100.2.5. And the web port for that is port 80. And check. We'll give it some time to finish. Let's scroll down, and we'll look at the results. That tells us that access is denied, and it's also showing us the network security group and the security rule that's blocking. Perfect, we can use the IP flow verify tool to troubleshoot connectivity issues. As promised, we'll review application security groups next. With our current configuration, any client from the 10.100.1 subnet can access any web server in the protected 10.100.2 subnet. What if we have a multi-tiered web application with servers that should not be available outside the subnet? We can change the destination to only include the IP addresses of the front-end web servers, but that's cumbersome to manage, especially in larger environments that have multiple servers or scale sets that automatically add servers to a pool. Instead, we use an application security group to group our resources together, then use the ASG as the source or destination for a rule. We can then update the rule logic without updating the NSG rules itself. This is especially helpful for complex environments where groups of VMs are members of multiple rules. In the example coming up, we create an application security group and specify that as the destination instead of any. That limits the traffic to the servers that are members of the ASG. If we change our front-end web servers, we simply update the ASG. Let's go back to the Azure portal and set up our application security group. Let's create an application security group next. So far, we created our rules using IP addresses or a range of IP addresses. We can define groups of like servers that make up an application and target that instead. That way, we don't have to update the rules if the IP addresses or the systems change, just the ASG membership. Let's start by going to client 1 and remove the deny rule we configured earlier. We'll go to networking, outbound port rules, find the deny rule we created, and move over to the left. Here we have the option to delete the rule. Delete that rule. This demonstrates how to remove the rule from network settings, and it cleans up the rule if you want to do any tests with application security groups. Now that we have that cleaned up, search for application security group. There it is. We'll open up application security groups. We'll create a new application security group. Select our subscription and resource group. You can also add a new resource group if needed. We'll give it a name, Web App Sec Group for this example, and select our region. It has to be in the same region as the NIC we'll attach it to. Add tags as needed and go to Review and Create. Once validation finishes, great. We'll give it a few seconds to finish. Once it's finished, go to the resource. There isn't really much to do from the resource. Let's associate it to a NIC next. For this, let's go to Web 1 in the Azure portal. Here we are at our VM Web 1. Go to Networking. From here, go to Application Security Groups. Select the option to configure the application security group. Select the application security group we set up previously, Web App Sec Group for this example, and save. That assigns the application security group to this NIC, and keep in mind we can assign multiple application security groups to a single NIC. Next, let's go to Web 2. From here, we'll go to Networking, Application Security Groups. We'll configure the application security group and add it to the same one. Now both servers are part of the same application security group. We'll use the application security group in a network security group next. Let's go to our network security groups. And from here, we'll locate our web in network security group. There it is. Let's modify our two inbound web rules to be more specific, so they target an application security group as a destination. Let's open up the HTTP in rule. The destination is set to any, so it will apply to anything behind the rule. Let's change that to application security group. Add the application security group we created previously, Web App Sec Group. Notice we can add more than one ASG. We'll save. Next, let's go to our HTTPS rule. Instead of the any destination, let's change it to application security group. And we'll select our ASG and save. Now, our two allow inbound rules use a more specific destination of the web app security group. That is how to create an ASG and use it in a rule. That is what you need to know about network security groups, application security groups, and how to verify IP flow. Please, if you found this useful, show your appreciation by subscribing to this channel. Thanks for watching.